Welcome to another video on my BeagleBoard Classic revision 3, which has a connection to that monitor using HDMI, also to connection to laptop via RS232 serial connection, and via USB connection to both network via USB to Ethernet connection, as well as also via this hub to this fischertechnik row interface. BeagleBoard is running Ubuntu Linux, a little bit outdated version, but that's okay, and is programmed in Python. And through Python it controls this roller track, so the program does not run on the robo interface. Everything from the motors is controlled by pulse width modulation. So here's a motor, and right there is a motor. Let me replace it. So down there is a motor, and here's a motor for this chain. And let me carefully move the camera. So a chain right here. So obviously the purpose is to get balls like these through the chain right up, and then through the roller tracks either this way or this way to this chain. Now here's another ball which is supposed to be down there, and the problem right now is that the balls are not staying here, they are rolling back depending on how much weight there is for the balls, but also a little bit annoyingly, balls don't always get here. Balls stay here or along any place there. So last time I reconstructed this support, and let's see how it works out this time. So let's put some balls in. But before I put some balls in, let's check the software again. VNC, because straight on the BeagleBoard is going to be a bit well, cumbersome. I've tried in the past to get the keyboard as well as a mouse right here connected to this USB hub, but then I get all kinds of synchronization and detection errors, so I keep it to the VNC. Also I would need this to watch anything at all on this monitor, but either that HDMI cable or the monitor is not quite right, and I suspect both of them, by the way. So if I look right here, you can see that this track is selected. So I am going to take this ball, put it high up, and see whatever happens. And that is not going good. I wonder why. Right. Let me try again. So putting it up high here, Now it goes a lot better, but ends here, which is not what I like. And once again, and then it is very nice if I actually drop it into the track. And now it ends up here. Not good either. Alright, then what I can also do, just put it right here. And then it goes all the way to the end. So put the camera a little bit back. That's better. Now I can have the whole track in, or almost the whole track, from the same point. See, that is what I want to see. So now the whole track again. So why does it end up here then? And from this point, exactly the same thing. Okay, now I push a little bit and then it works out. Okay, so it needs a little bit speed from up here, right here, to make it right there. But still, this is a loose part. Then I'm talking about this one, which keeps an angle in it, so I need to change this. Let's start with that. Right, I have made a small reconstruction addition right here. This is movable, but the most important part is where is it, what position, and I think this is the best position. So if I take this ball and I let it run, then it works. But will it run when I have more balls? Because that is the idea. So I want to have all balls available, and then that happens. So I need to be a bit careful. And because it is able to move, well, that is a bit of the danger. Anyway, let's run the program and see whatever happens. And now you can also see that this happens. So it still isn't exactly what I need. So take the camera. That is one, but one is clinging, not anymore, not taken, another one not taken, oops, and here a ball is missing. And now something else happens, so I'll shift them through, but now it is depending on this ball again. Now it's taken, that number 2, and again clinging. Now here a ball is being taken, so either it loses its either the motor is strong enough to lose it, or whatever. No, because it's the other trajectory. So I'll help, and I have to help here as well. So this is not good. And here is not good either. Nope. Stays here. So whatever is happening, it is not very good. Let me add some light. Ball running back, and then that one stops here. So this isn't the solution either. And neither is this one. So somehow, somewhere along the track, kinetic energy is lost, and lost at different moments, unfortunately. And maybe somehow it's good to be not as strong, but now two balls are waiting. Let's help. And now it gets 4. So it really needs help. So let's chase this one again. And yeah, so that goes quite well, as is supposed to be. Right, let's go to the other track again. So that works well now. Nope, not good. Not good. And not good. So still problems, and lots of them, unfortunately. So in conclusion, I'm not quite sure that this is going to help, even more since the ball, any ball ends up here, here, here or here, and then I even have to help the balls getting to the end if they end up here. Apart from that, of course, a ball that ends up here when the magnet is unable to being to separate, or the track separates the ball from the magnet, which does happen, by the way, always at the top. Saying that, it may be the shear speed, so let me off track just take a look at it. And as far as I can see, all motors are running speed 1. So that is not the point. Now I do know that all motors of the same type are not exactly the same, so they don't run exactly the same speed. But then why is the top of the track with the long, why is it here always happening and why is it here not always happening? So with that question I say thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, always appreciated. You can also follow me via Instagram and Twitter. Please show your appreciation by making a donation via either PayPal or Wired, or you can also become a patron, and depending on the pledge you make, may have your name mentioned on my website and with my videos. For more information, please see under this video. For now, to be continued. Have a nice day and bye bye.